Assalamu alaikum. In this video, we'll talk about how to graph sine and cosine function. We will recognize and graph the periodic and trigonometric sine and cosine function, and we'll see these words in this video: periodic function and cycle period, and amplitude and the phase shift. Okay, the periodic function are a function that repeat exactly in regular interval called cycle. The length of the cycle is called period. A cycle may begin at any point on the graph of a function. The amplitude of sine and cosine function is a half of the difference between the maximum and the minimum values of the function. The amplitude is always positive. So you can graph the function f of x equals sine x on the coordinate plane by using the y values from the point of the unit circle where the independent variable x represent the angle theta in standard. So if you want to graph the function y equals sine x, it's easy by using this table, and I will choose the independent value of x, 0 pi over 6, pi over 2, and 5 pi over 6, and pi and 3 pi over 2 and 2 pi. These values give me 1 and half and 0. So this is why I choose this value. So this is after substituting each value in the sine x, I'll get this value in the answer. So this is the values of y. So on the xy plane, by plotting each point and then connecting the points by the graph. So this is the graph of sine y equals sine x. So on the graph, this is the period of the function and this is the amplitude of the function. So the amplitude here is 1 and the period is 2 pi. So similarly, the function f of x equal cosine x can be graphed on the coordinate plane by using the x value from the points on the unit circle. So this is y equal cosine x, and this table I can choose the independent value x by choosing these values: 0 pi over 3 and pi over 2, 2 pi over 3 and pi, and 3 pi over 2 and 2 pi. After substituting each value in the function, I'll get these values. On the xy plane, do the same things. Plot the points and then connect the points by the graph. So this is the graph of cosine x. So this is the period of cosine x, which is here again is 2 pi, and the amplitude is again 1. Okay, so 1, the amplitude and the period is the same for cosine and sine. So we can see here that for both sine x and cosine x, this is the graph for each function, and the domain always for both sine x and cosine x is a real number. And the range is between -1 and 1. The period for both function is 2 pi, and the amplitude is 1 for each sine x and cosine x. But the question is, how can we find the period and the amplitude? Okay, so the formula of the parent function for sine x and cosine x is y equal a times sine bx and y equal a times cosine b of x. Now, recall that a indicates a vertical stretch when absolute value of a is bigger than 1, or compression when the absolute value of a between 0 and 1 mean that it's a decimal number, so which is change the amplitude. If a is less than 0, mean that it's negative, so the graph is reflected across x-axis. The values, the value of b indicates a horizontal stretch or compression, which is change the period. So the amplitude here, if you want to find the amplitude, it's the absolute value of a direct. Take the number which is multiplied by the function, and this is the amplitude. But the period, you have to take the value of b, and then you have to divide 2 by the absolute value of b to find the period. So look to this example. Using y equals sine x as a guide, graph the function g equal half sine of half x. Identify the amplitude and the period. Okay, so step number 1, identify the amplitude and the period. This is the a and this is b. So a here equal half and b equal half. Because the value of a equal half, so the amplitude direct is the absolute value of a, which is here is half. So the amplitude is half. Now, since b equal half, so the period is 2 pi divide the absolute value of b. So here it's 2 pi over the absolute value of half, which is equal after calculation 4 pi. So the amplitude here equal half, and the period is. So here the curve is vertically compressed by a factor of half, and it's horizontally stretched by a factor of 2. So actually this is the value of A, and this is the value of 1 over B. Now if you want to draw the graph, the function of g, you have to start always from the table of sine x, y equals sine x. So this is the table of y equals sine x. Now, since here the value of a is half, or the vertically compressed is half, so you have to multiply each value of y by half. And since the horizontally stretched is by a factor of 2, so you have to multiply each value of x by 2. So let's start from the values of x. We will multiply it by 2, which is here the horizontally stretched, or the factor of the horizontally stretched. And then we will multiply the values of y by half, since half is the factor of the vertically compressed. Okay, after that, do the calculation, and this is the new table. So the new table is actually for the function g equal half sine of half x. Now this is the new values for x, which is 0 pi and 2 pi and 3 pi and 4 pi. The new values of y, it's 0 and half, 0 and negative half, and 0 after doing the calculation. Well, this is the graph of the parent function y equals sine x by using the table of sine x, but this is the graph of the new function g equal half sine of half x, and this is here the amplitude, which is half, and the period here is 4 pi for this function. Okay, so you can combine the transformation of trigonometric function. Use the value of a and b and h and k to identify the important features of the sine and cosine function. So this is the general formula for the sine x. Okay, it's y equal a sine b of x minus h plus k. Now, a is the amplitude, b it's for the period, but h here is for the phase shift, and k is for the vertical shift. The phase shift means that when you shift the graph for left or right, the vertical shift, when you shift it for up and down. And it's the same for cosine x, the same formula and the same. Okay, look to this example. Using y equal cosine x as a guide, graph the function g equal 2 cosine 2 of x plus 5 minus 3. Identify the amplitude and the period. All right, so the first step here, before finding the value of a and b, you have to take the common factor from this brackets. Actually, the common factor is dividing by the coefficient of x, which is 2. You have to take 2 out by dividing both term by 2. So it will be like this. G equal to cosine 2 in the brackets x plus 5 over 2 minus 3. Why? Because I have to show the phase shift. Now, the value of A is 2, the value of B is 2, the value of the phase shift, which is here H, is 5 over 2 or negative 5 over 2 because you have to opposite the sign, and the value of K, which is the vertical shift, is negative 3. So A equal 2, B equal 2, and here H, which is the phase shift, is negative 5 over 2. As we mentioned, we have to opposite sign, and K, which is the vertical shift, is negative 3. So let's start with the amplitude. Here the amplitude direct is 2, since 2 is positive number. And the period, you have to divide 2 pi by b. b here is 2, so 2 pi divide 2 is equal pi, so the period equal pi. Now, the phase shift here is 5 over 2, which is 2.5. So mean that 2.5 units to the left. Okay, and the vertical shift here is 3 units down. Since it's negative 3, negative 3 mean you have to shift down 3. Okay, so to draw the graph, as we mentioned it in the example of the sine x, start from the table of y equal cosine x. So this is the table of y equal cosine x. Now, here, the curve is vertically compressed by the factor of 2 and horizontally stretched by a factor of half. 2 is the value of a, and half is 1 over b here, which is half. Now, multiply the value of x by 1 over b, and multiply the value of y by a. So the new table for y equal 2 cosine 2x is these values: 0, pi over 4, pi over 2, 3 pi over 4, and pi, and the value of y is 2, 0, and negative 2, and 2. Now, after that, we have phase shift 2.5 units to the left, mean that we have to add negative 2.5. So actually here, you have to do this. Only the values of x, you have to subtract 5 over 2 from each value of x. Don't change the values of y. The values of y never be changed. Just here, we will change the values of x. Since it's horizontal shift, so in the horizontal shift, we will change just the value of x. So this is the new table now for the after the phase shift. Now, we have vertical shift 3 units. Vertical shift 3 units mean you have to subtract 3 from each value of y. Now, this is the new table and the last table for the graph function. The vertical shift, just we will change the value of y, but the values of x, we will not change it after the phase shift. Now, this is the graph of y equal cosine x, which is the parent function. Now, this is after the amplitude, with the amplitude, the value of a and the value of b. Okay, and this is after doing the phase shift, and this is after doing the vertical shift, which is the last graph of the function. Okay, so here in this video we talk about the general formula for the sine x and the general formula for cosine x. The amplitudes can be found by finding the absolute value of a, and the period by dividing 2 pi over the absolute value of b. Now, the phase shift is always h, and the vertical shift is always k. So this is about how graphing sine x and cosine x, how finding the period, and how finding the amplitude and the phase shift, vertical shift. Thank you for watching us. See you in next video, inshallah.